So our power network needs flexibility, but also storage capacity. And we are moving to this second issue with the next presentation. So I call Emanuele Quaranta to join me here from Jersey, and he will talk about sustainable development of pumped hydro storage.
Grazie. Thank you very much. Thank you for the invitation. I am Emanuele Quaranta. I work at the European Commission on water topics, in particular hydropower. In particular, I work at the Joint Research Center of the European Commission. I'm sure that most of you don't know that the European Commission has a research center. And the aim of the research center, in particular, I am in the Ocean and Water Unit, is to perform scientific assessment in order to provide scientific support to the European Commission and to the legislation. In particular, that I work in the water field, our unit works in different kinds of water, from the ocean to the rivers, hydropower, water in cities, for agriculture, for example. Here are all the directives where our unit has been involved in order to support the European Commission in this different legislation. Today I will talk about sustainability in hydropower with focus on pump storage hydropower plants. As you know, hydropower is at the center of a big debate because it is renewable, so a lot of benefit for the clean transition, but on the other hand, there may be also some impact that could be generated, especially when a new dam is installed in a river. On one hand, indeed, we have a lot of benefit that hydropower provides, renewable energy, flexibility, storage, but also export capacity. We have to think that if we consider all the global export of hydropower equipment, the European Union companies hold 50% of this, so also more than China. But on the other hand, there may be some impact that we should not ignore, as for also all the other energy technologies, there are impacts also for hydropower, especially on fish, on sedimentation, on river fragmentation. And this conflict can also be seen in different directives of the European Union. On one hand, we have, for example, the environmental directive, like the Water Framework Directive, Directive Aquawatt, where hydropower is an impact. But on the other hand, we have the Renewable Energy Directive, where hydropower is key to the energy transition. Then there are other contexts, like, for example, the floods, so le piene, le alluvioni, where barriers in river can exacerbate by obstaculating river flow, so can still exacerbate the floods, but reservoirs, on the other hand, can store water and mitigate floods. So also in this case, we have different conflictual targets of hydropower and reservoirs. So in order to achieve sustainability in hydropower, we need to find where there is the balance between the impact and the benefit. And so try to promote sustainable solutions and sustainable strategies for hydropower. And this is the topic of today. I will show you some potential, some numbers. So how much more hydropower in a sustainable way we can build with focus the European Union. In particular about pump storage hydropower. Just a few words about pump storage. Pump storage are constituted generally with two reservoirs, sometimes more reservoirs, connected with pumps and turbines. It is possible to pump water where we need to consume energy, and when we need to produce energy, we activate the turbines. We can distinguish between closed loop and open loop. Closed loop are when pump storage hydropower plants are not connected with rivers, while open loop when they are connected with rivers. Why are important the pump storage hydropower plants? Because if we consider all the energy storage technologies, so mainly batteries, pump hydro, hydrogen, pump hydro storage hosts more than 90% of energy storage capacity. If in these numbers we also consider traditional hydropower reservoirs, they practically store almost 100% of energy storage capacity. Where are located pump storage in the European Union? This is a picture taken from the website of the International Hydropower Association, and you can see here that most of pump storage hydropower plants are obviously in the Alpine context. And in the European Union, the installed capacity in turbine mode of pump storage hydropower is 46 gigawatt, That is more or less 25% of the global installed capacity of pump storage. So European Union, also in this case, is a leader in pump storage hydropower plants. And if we have to say how much is the energy storage in pump storage hydropower plant, what is the energy storage? We define energy storage in gigawatt hour, the amount of energy that can be generated in one cycle. And this is more or less 1,300 gigawatt hour. So if all pump storage hydropower plant could generate altogether energy in one cycle, that would generate 1,300 gigawatt hour. These are estimates. Obviously, the result may change a bit, but more or less this is the order of magnitude. Okay, now I will show you some sustainable option. The first slides are on this topic. So how is possible to increase this energy storage capacity by simply improving the operation of the existing pump storage hydropower plants? So by improving the operation, this means that no new barriers is added, so no new impact, only benefit. The first option is to modernize them. We'll carry out an assessment, generally for hydropower, with new technologies, digital solution, new electromechanical equipment, new waterways and penstock. We can increase energy generation by more or less 10% at the European scale. Obviously, pump storage hydropower are more important not for energy generation, but are more important for flexibility. And I will not go into the detail because already Matteo in their project X-Flex already explained very well how pump storage can be upgraded in order to improve flexibility. So for example, with variable speed turbine, short circuit operation, digital solution. And why it is important to refurbish pump storage, in general hydropower. Here you see the increasing of installed turbine capacity in pump storage hydropower over the year. You can see that there has been a boom after the Second World War, so around 1960, 1980. Then in the last year, there is an increase, but very slight. And so most of pump storage hydropower plants fall in the category 1960, 1980. So they are quite old, 50 years old. So there is a need of refurbishing them. Another option in order to increase the storage capacity of reservoir and of pump storage is, for example, to increase the height of the dam where it is possible. There has been a study and several case studies in Switzerland, for example, that by increasing the height of the dam between 5 to 10%, is possible to increase the storage capacity at the national level, so for all Switzerland, by 30%. And this reasoning could be more or less extended to all the Alpine context. Also, the sedimentation is important because every year, more or less, 1% of the storage volume is lost due to sedimentation. And this limits, obviously, the storage capacity. But dredging has also a cost. Enel showed also some cost of some euros per cubic meter. If we extend this analysis to all the European reservoirs, we came, with some calculation at the cost, that dredging more or less costs between 2 to 8 billion euros per year. So the sedimentation is important, but there are also costs. So now the second approach, is possible to build new pump storage without building new dams? Yes, by, for example, using existing structure or existing infrastructure. The first is the using of abandoned mines. There is a European project called Atlantic that is addressing this topic in order to use abandoned mines to create pump storage hydropower plants. And according to some calculation, always at the European scale, the potential of the most economic site is 3 terawatt hour. If you remember, I say that more or less the current storage capacity in pump storage is 1.3 terawatt hour. Using abandoned mines can still increase this by 3 terawatt hour, so more than double the existing capacity. Another option is to interconnect existing reservoirs or existing hydropower plants. And obviously, depending on the distance between the reservoirs, the potential can increase or decrease. If we assume, for example, to interconnect a reservoir within 20 kilometers, we have a potential of 14 terawatt hour. If we consider, more realistically, to connect only reservoirs, for example, within 5 kilometers, which is a reasonable distance, we have 800 gigawatt hour. Obviously, these are estimated potential at the European scale. They are not exactly the number, the fact. They are estimation that are very difficult to perform, because when dealing with this estimation on the European scale, we sometimes have a lack of data, and we have to do some assumption and so on, also involving external experts. But in any case, even if they are approximated, they show the order of magnitude, so the importance of each strategy. So it is 1, 10, or 100. This is what matters at the European scale. Then obviously at the local scale, more sophisticated calculation should be carried out. Then another option, so the last option, is possible to better operate the pump storage hydropower plants and the overall energy system in order to reduce the need of storing energy. Yes, for example, as also some case studies showed by Enel, the hybridization is very important with photovoltaics, both with floating photovoltaics, but also with photovoltaics on the face of the dams. Installing photovoltaics on the face of the dam is not very usual, so I'm very happy that there is an Italian company that is doing this. But it's possible to hybridize hydropower and pump storage also with batteries, as also Matteo Bianciotto explained. And also it's possible, another strategy is to extract the heat from the cooling system of the generator. There are already some case studies on this, and using this heat for district heating or for warming the building near the powerhouse. So there are different combinations, and also research projects on this. So these are reality, it's not just theory. Okay, floating photovoltaics, there is an assessment at the European scale. By supposing to install floating PV in the most suitable reservoir in the European Union, we can produce more or less an additional energy generation of more or less 50% of what the hydropower now is currently generating. And it is possible also to reduce evaporation and so to add additionally 300 gigawatt hour per year. It is possible also to expand the grid, and there has been this very nice study, which is, I would say, not now very realistic, but in any case is an idealistic scenario that allows us to think a bit. If we suppose to interconnect all the hydropower plants, the photovoltaics plant, and the wind power plants over Europe, so very idealistic, but just to think, it is possible to reduce the need of storing energy by 200 terawatt hour every 5 years, which is a lot. But this need to improve a lot the grid. Another solution to improve the operation of pump storage, as also discussed this morning, is to operate the reservoirs not as a single-purpose reservoir, so not only reservoirs for hydropower or for pump storage, but also for other purposes, like, for example, for flood control. This is a figure that I took from the ICOD on the use of reservoirs in the European Union and Switzerland. You can see on the left that more or less 70%, so 2/3, 2/3 of water reservoirs, of the largest water reservoirs, large dam in the European Union, are for only one use, and only 1/3 are for multiple uses. But if you look on the right, the 70% of dams for single uses store only 50% of the volume. So the multi-purpose reservoirs are less, but store more or less the same amount of volume of single-purpose reservoirs. So now the last topic is possible to build new pump storage, so from scratch, so also in near rivers, so new pump storage with new reservoirs. There has been another study at the European scale that has identified all the possible sites where it is possible to install pump storage hydropower plant from a topographical point of view. Then obviously locally there may be some environmental constraint, the cost may be high, and not all will be feasible, but at least from a topographic point of view, there is still a lot of room in the European Union and Europe for pump storage hydropower plants. Up to 300 terawatt hour, which is one order of magnitude more of what we have now. Obviously, not all are possible due to problem of investment cost. This was, sorry, the last slide was for closed loop hydropower. This is for open loop hydropower, pump storage hydropower. So for pump storage hydropower connected to river, and even if in the European Union, Europe, there is a potential of 10 terawatt hour, more or less. Another option is to use the ocean, the ocean can be or used as the lower reservoirs and pumping water to an upper reservoir, but there are problems with salinity of water, but there are still some projects in progress on this, or using another technology now under development, under research, is the one on the right, sorry, on the left, of installing this sphere on the seabed. There are problems, obviously, of cost and of the aggressivity of the water in the ocean. So last slide, now not on pump storage, but on traditional hydropower. So it's possible to improve, to increase energy generation and create new hydropower plants without building new dams. Yes, it's possible. The first, as I said already, refurbishment. Refurbishment is very important, not only to increase energy generation. More or less, we estimated that we can increase energy generation by 10% in Europe by using digital solution, new electromechanical equipment. But by refurbishment is also important because we can increase flexibility, sustainability, safety, adaptation to climate change, and also for water resource management. It's possible also to repower existing small barriers that already exist. So we don't need to build new barriers. There are already in the European rivers, it has been identified more or less for more than 400,000, so 450,000 barriers in rivers. They could be used for small hydropower, and the potential is 8 terawatt-hour per year, so more or less 3% of what is generated today by hydropower, by supposing to repower all these barriers. Then another topic is the one from hydrokinetic turbines. In the European Union, this is not a very high potential because, as you can imagine, rivers in Europe and European Union are generally shallow and quite slow. So the potential for hydrokinetic is not so important. Finally, it's possible to develop hydropower, for example, in water distribution network and in wastewater treatment plants. Generally, also in this case, it is small hydropower. And additionally, here the potential could be 3 terawatt-hour per year, so more or less 1% of what is produced today. Here are some key references, and I would like also to say this, that in a few weeks, the hydropower and pump storage report of the European Commission will be published. I will leave some leaflet here if you want to collect it, and in a few weeks it will be available. It is published every year, and the comments from all type of stakeholders are very welcome. So if you read it and you find something that you would like to comment, you can send me your opinion. And sometimes we have also included some comment of companies in this report. So thank you for your attention. I show several numbers in this presentation. Again, these numbers are estimates, and so they suffer of a certain uncertainty. But in any case, they show the order of magnitude of priority. No? So if we found 100 as number, this means that this is more important than the strategy that showed 10 as number. Then this 100 could be 110, 90, but more or less the order of magnitude is that. And thank you. I'm very happy also to hear your comment, your criticism. These are all scientific studies, so critics are very welcome. Thank you.